Welcome to our deep dive into recomposition in Jetpack Compose. If you're building Android apps, understanding recomposition is crucial for creating responsive and efficient user interfaces. In this video, we'll explore what recomposition means, why it matters, and how you can leverage it to optimize your app's performance. We'll break down the core concepts, walk through practical examples, and share actionable tips to help you avoid unnecessary UI updates. Whether you're new to Compose or looking to refine your skills, this guide will equip you with the knowledge to make your UIs smarter and faster. Let's get started by defining recomposition and seeing how it fits into the Compose framework. Composition is the process by which Jetpack Compose updates the UI in response to state changes. Unlike traditional Android views, Compose uses a declarative approach, meaning only the affected parts of the UI are redrawn. This makes updating your app's interface faster and more efficient. When a piece of data changes, Compose reevaluates the relevant composable functions and redraws just those elements. By understanding recomposition, you can prevent unnecessary UI updates and ensure your app remains smooth and responsive. Let's see how this works in practice and why it's a game changer for modern Android development. Jetpack Compose composable functions react to state changes. When the state of composable depends on changes, the function is re-executed, updating the UI automatically. This is similar to reactive programming, where UI elements update based on the data they depend on. For example, if you have a counter that increments when a button is pressed, only the counter display is redrawn, not the entire screen. This targeted approach reduces overhead and keeps your app running efficiently. Understanding this mechanism helps you design UIs that respond quickly to user interactions. Let's look at a simple example to illustrate recomposition. Imagine a CounterScreen composable with a count variable. When the button is clicked, count increases, triggering recomposition. The UI updates to show the new value. This is achieved using remember and mutableStateOf, which make count a state variable. Every change to count causes the CounterScreen to recompose, ensuring the displayed value is always accurate. This example highlights how Compose efficiently manages UI updates without redrawing the entire screen, making your app more responsive. Composition happens in several scenarios. First, when state variables created with mutableStateOf change, any composable reading those variables will recompose. Second, if a composable function has parameters and those parameters change, recomposition is triggered. Third, when a composable with a key value detects a change in the key, it recomputes that specific instance. By understanding these triggers, you can better control when and how your UI updates, preventing unnecessary recompositions and improving performance. Efficient management of recomposition is key to writing optimized Compose code. One important tip is to use remember to save computed values, preventing costly recalculations. For example, expensiveCalculation can be stored with remember, so it's only computed once and reused across recompositions. Limiting the scope of recomposition by breaking complex UIs into smaller composables also helps isolate state changes and avoid unnecessary updates. These strategies ensure your app remains fast and responsive, even as it grows in complexity. Another powerful tool for managing recomposition is derivedStateOf. This function creates a new state based on other states and only triggers recomposition if the calculated state's value changes. For example, you can use derivedStateOf to combine firstName and lastName into fullName, and Compose will only recompose when either name changes. This approach avoids redundant recompositions and keeps your UI efficient. By leveraging derivedStateOf, you can build dynamic interfaces that update only when necessary. While remember is useful for caching values, it's important not to overuse it. Excessive use can keep references in memory longer than needed, potentially leading to memory leaks or performance issues. Be mindful of what you cache and ensure you're only storing values that truly benefit from being remembered. This careful approach helps you maintain optimal performance and prevents your app from consuming unnecessary resources. Let's explore a more detailed example, a shopping cart. In this composable, item count and total price are state variables. Each time an item is added, both values update, triggering recomposition. The UI reflects the new total items and price instantly. This demonstrates how Compose handles multiple state changes efficiently, ensuring the UI stays in sync with the underlying data. By structuring your composables this way, you can build interactive features that respond quickly to user actions. Sometimes, recomposition affects parts of the UI that shouldn't change. For example, if a parent composable updates, its child composable may recompose even if it doesn't depend on the parent state. To avoid this, you can extract child composables into separate functions or use remember for more granular control. This prevents unnecessary recompositions and keeps your UI stable. By isolating state changes, you ensure only the relevant parts of your interface update, improving both performance and user experience. Key function is another tool for controlling recomposition, especially in lists or collections. By assigning a unique key to each item, Compose ensures that only the changed items are recomposed, not the entire list. For example, in a names list composable, the key function helps manage state changes efficiently. This targeted recomposition is essential for building scalable and performant UIs, particularly when dealing with dynamic data sets. Testing recomposition is vital to ensure your UI updates as expected. You can use print statements or logging to check when recomposition occurs, but tools like Android Studio's Layout Inspector provide real-time insights. These tools help you visualize what composables are recomposing, making it easier to debug and optimize your code. By regularly testing and monitoring recomposition, you can catch performance issues early and maintain a responsive app. Let's recap the main takeaways. State changes in composable functions trigger recomposition. Using remember and derivedStateOf wisely helps optimize recomposition by caching values and creating dependent states. Limiting the scope of recomposition by breaking complex UIs into smaller composables gives you more control. Testing and debugging with tools like Layout Inspector ensures your UI updates efficiently. By mastering these techniques, you'll build UIs that are both efficient and responsive. Understanding recomposition empowers you to create dynamic, reactive UIs in Jetpack Compose. By following best practices, you can minimize unnecessary updates, improve performance, and deliver a smoother user experience. Efficient recomposition management is essential for modern Android development, ensuring your apps remain fast and scalable as they grow. With these skills, you'll be ready to tackle complex UI challenges and build apps that stand out. Thanks for joining us on this journey through recomposition in Jetpack Compose. By mastering these concepts, you'll be equipped to build efficient, responsive, and scalable Android UIs. Remember to use state wisely, optimize recomposition, and leverage testing tools for best results. Stay curious and keep exploring new ways to enhance your apps. With Jetpack Compose, the possibilities for innovative UI design are endless. Happy coding!